Hey, good morning. I just wanted to have this quick video to emphasize a few things as we're coming to the end of this chapter. So, first off, with the unit circle, as many of you guys are starting to become more and more familiar with this, that's good. Some of you even are starting to memorize some of these answers. I'm glad. The better you know the unit circle, the easier the rest of this semester will be. So, continue to do that. However, I want to point out something that has caused a little bit of problems. So, whenever we're using the unit circle and we are asked for sine, remember we can find sine just by finding whatever the y value is. And the reason that is because we know the radius is 1. So like if we had a triangle here, let me actually draw that in quick. So if I have a triangle here, this angle is our, whoops, let me fix that. This angle right here is our theta. Okay, so we know if that is our theta, then this is opposite, this is adjacent, and this is our hypotenuse. So SOHCAHTOA still applies. However, the difference is whatever the y value is, since our hypotenuse is 1, whatever this is divided by 1 will automatically just be that y value, because anything divided by 1 does not change, right? 200 divided by 1, still 200. So whatever this y value is, that's going to be your answer. So that's why on a unit circle, we can just use this value of y as our sine. However, that's not always the case. If we think back, this was on, let's see, what was this? The second day, 6.2, back a little while. It says, for the point 3, -4, find the exact value of sine, cosine, and tangent. Now, when we're solving this, right now, or back in the beginning, you guys knew what to do. You use Pythagorean theorem to find it. Then you use SOHCAHTOA to find what sine, cosine, and tangent is. Unfortunately, some of us are using our knowledge of the unit circle now and getting confused. We're assuming that the sine is the y value, and you guys are writing the y value as negative, or sorry, the sine as -4. However, we can't do that because this is not in the unit circle. So on the unit circle, since the hypotenuse is 1, it's just -4 divided by 1. Here we need to use so, right? So O over H. So we have to find our H before we can solve it. So just to recap, I know this is in your notes, but if we had the point 3, -4, let me draw our little triangle over here. So we know that would be 3, that would be -4. It's a right triangle with our theta there. So already we know that this is our hypotenuse, this is our adjacent, this is our O. So before we even did anything, you could find your tan, right? Tangent, TOA. So tangent of theta, TOA, so -4 over 3. Okay, but we also need to find what sine of theta is and what cosine of theta is. Now, once again, some of you are tempted just to say that sine is -4, cosine is 3. That is only the case if h was 1. In our case here, h will not be 1. So we're going to use a squared plus b squared equals c squared. So 3 squared plus the -4 squared. If we add that together, we will get c squared. So 9 plus 16 equals c squared. And we'll get 25 equals c squared. When we take that square root, both of those, we get c to be 5. It's a nice Pythagorean triple here. Okay, so now, as you can see, while some of you were tempted probably to say that the sine was just y, that's -4, it's actually going to be -4 over 5. Some of you were probably tempted to say cosine is x, that's 3. It's actually 3 over 5. So this would be our answers. As you can tell, a little bit more complicated because we have to worry about the hypotenuse. The difference was, remember, on the unit circle, we already know that the hypotenuse is 1 because the radius of the unit circle is 1. So that allows us to skip that step, and rather than dividing by 1, I just know if y is 1/2, that is my value of sine. So please be careful. When it's on the unit circle, we can use that. We know sine is y, cosine is x. When it's not in the unit circle, you have to use SOHCAHTOA. Hope you guys have a great day. If you need any help, let me know, and continue to get ready for the test.